Chapter 3, Lesson 1, Graphing Linear Equations. So the first thing we're going to look at is, what is a linear equation? So linear equation is just an equation that forms a line when it is graphed. Okay? And the standard form of a linear equation is, it's going to look like this. AX plus BY equals C. And so A is going to be a number value, B is going to be a number value, and C is going to be a number value. Now, it's okay if sometimes if some of those are zeros, but here's our rule, is that A and B are not both zero. One of them can be zero, but both of them cannot be zero. And it's okay if C is zero, but A and B cannot both be zero. Otherwise, our equation is just C, and that's kind of weird. So the other rule is that A must be greater than or equal to 0 when we write it in standard form. Sometimes it won't be bigger than 0, but we can change it. And that the GCF, the greatest common factor of A, B, and C is 1. So they don't have any common factors. If so, then we're going to simplify it to make sure that it does not have a GCF bigger than 1. Okay, so let's look at some examples. So if we're trying to decide if an equation is linear or not, is what we want to do is we want to try to get it in standard form. So the first one says y equals 4 minus 3x. So remember, standard form is ax plus by equals c. So what I need to do is I need to get the two terms that have the x in it and that have the y in it on the left side. Well, my y is already over here on the left side, but my 3x is over here on the right side. So I'm going to do plus 3x and plus 3x to move it over on the other side. So then instead of writing y plus 3x, I notice that standard form says x plus y. So I'm going to put 3x plus y equals 4. Okay, so it kind of looks like above, right? So this is like ax plus by equals c. Okay, so it looks like standard form. And then I want to say, well, are there any factors that can go into 3? Because a equals 3, b equals 1, and c equals 4. Do 3, 1, and 4 have a greatest common factor besides 1? No, they don't have any common factors. So this is linear. And here's my equation written in standard form. All right, let's look at the next one. So we have 6x minus xy equals 4. So I look at that and I say, okay, I'm going to get it in standard form. So I have, okay, here's my term like ax, and then plus, by. Well, b needs to be a number. It can't be x. And so this is not a linear equation, because we cannot get it into standard form. Now let's talk for a little bit about what the x-intercept and the y-intercept of an equation mean. So an x-intercept is where a line crosses the x-axis. So if I think about a graph and I have a line drawn on that graph, then my x-intercept is going to be this place right here where that line crosses over the x-axis. And that x-intercept is always going to be some number, and that's going to be our x value, 0, because it's not going to go up or down. So my ordered pair will always be some number, and then 0. My y-intercept is where a line crosses the y-axis. So if I have a graph and have a line, my y-intercept is right here where that line crosses the y-axis. And that is always going to be 0y, or 0 and then some number. If I'm looking at a graph and I want to find the x and y intercepts, it's very simple. All I'm going to do is look where the line crosses the x-axis and y-axis and get the ordered pair. We just look at the line and we just find where it crosses the x-axis, that's our x-intercept. Find where it crosses the y-axis, that's our y-intercept. The equation is a little bit harder, but we just talked about that the x-intercept is like we say some x value and then 0, and the y-intercept is where we have 0 and then some y value. So in an equation is what I'm going to do is just what this ordered pair says. To find the x-intercept, I'm going to replace the y with 0 and solve for x. And I bet you can guess what we do to find the y-intercept out of an equation. We replace the, here's 0, the x with 0 and solve for y. Now, if I'm going to graph an equation using a table, right, that's kind of our XY chart that you might remember doing before, is what I'm going to do is I am going to choose any domain. Okay, remember our domain means our x value, and we can choose any of them, but we do want to be a little bit picky. We want to choose small ones. First of all, because they're easier, and second of all, because they're going to fit on our graph that we're going to make. Okay, so we're going to choose any domain. We are going to then find the range or the y value that goes with each domain, or the goes with each that matches with each x value. And then we are going to make ordered pairs, and then we are going to graph them. And they should make a line. If they don't, we made a mistake. They should make a line when we connect them. So let's do an example. So I'm going to make an XY table, and I'm going to choose some domains. We usually need to choose 4. So I'm going to choose small ones, 0, 1, 2, and 3. So then I'm going to plug them in. I'm going to find what y value matches with that x. So I might have to actually solve an equation. So if x is 0, I have 2 times 0 minus y equals 2. So I have 0 minus y equals 2. So negative y equals 2, which means that y equals negative 2. So if x is 0, y is negative 2. If x is 1, I have 2 times 1 minus y equals 2. 2 minus y equals 2. I subtract 2. Negative y equals 0, which means that y equals 0. All right, if x is 2, I'm going to plug that in, and I'm going to say, so 2 times 2 minus y equals 2. Lots of 2's. 4 minus y equals 2 minus 4. Negative y equals negative 2, so y equals 2. All right, and if x is 3, 2 times 3 minus y equals 2. 6 minus y equals 2, minus 6 minus 6. Negative y equals negative 4, so y equals 4. Okay, so then I make some ordered pairs. So I say, so this ordered pair is 0, negative 2. This is 1, 0. 2, 2, 3, 4. And then I plot them on my graph. 0, negative 2, 1, 0, 2, 2, and 3, 4. And I see that they make a line. I use a ruler and go through all those dots, and I have made my line that goes with that graph.